Yo, ugh, I can't hear you. You're not.
Oh, it's because my mic was turned off. Can you hear me now?
Yeah.
Okay,
You said she wasn't gonna make it today.
that's right. She had a dental appointment, and then uh, Courtney might still be at work. So we'll go ahead and get started. Let me share my screen.
I am trying to connect right now. Okay.
But we'll do the
And it
lecture
looks.
first. Yeah.
I know. I just. Hey, hey, hey.
Are you ready?
Hold on.
Okay.
I got a bunch of cats doing weird shit behind me. What's going on? Hey, hey. Okay. I think I'm ready.
Okay. Awesome. All right. Engineering bootcamp. So far last week we covered, what are the different components of a computer and how a program runs on them. You learned and wrote some C sharp code, and you started learning the basic structures of object oriented programming. uh, C sharp is a compiled language, and meaning that you had to run it and then it uh, executed as its own program. You only did that inside of Visual Studio, the IDE, but with a few extra steps, you could have actually generated an executable file that you could take to any computer and run. Um, so uh, this week we're learning SQL because it's how we store large amounts of data, and SQL is an interpreted language, so you're going to notice some differences between those. For example, instead of an IDE, you're actually using a database client program to put your queries into. When you write some SQL, it's called a query. Uh, so we also learned, and then the disadvantage for C sharp and is that you don't have any of your data stored. So every time you start over, you have to retype all your stuff, right? And with SQL, that's when we start getting in, and databases, that's when you start getting into being able to preserve some of that information. And then we also cover data structures such as classes, fields, and properties. So there's a lot of similarities between SQL and what you learned so far in C sharp. So typically, the every class that you have in C sharp, you would duplicate as a table in SQL uh, in your database. Then each instance of a class becomes a row in the table, and your fields and properties become the columns in the table. And like I said, the main reason is so that you can have all that large data and access it efficiently, even after the program starts and stops. So a table is a collection of the same type of records. So you would have one table that held all the characters, another table that holds all the spells, another table that holds maybe skills and equipment. And so each row in that table becomes one instance of that. Each column is one property. Uh, and you might have also heard about know SQL, that means not only SQL. And the reason I mentioned it is just so you're not confused by it. It's slightly different in that it stores unstructured data as opposed to what I'm teaching you right now, which is using structured data. And that's not really relevant to what we're doing in this class, but just so you know how it's different if you hear about it. So here's a good example. I think you should think about tables very much like spreadsheets. So we could have a student table, and the student class could have the student ID, first name, last name, gender, and grade level. And then each row becomes an instance of the student object. Does that make sense?
Mm-hmm.
Okay. And then because I like using classes all over the place, uh, you could also have a classes table that represents the name of the class, who's teaching it, what grade it's for, and maybe a description of that class, right?
Yeah.
Um, and so all of these would exist in the same database.
So, am I to get it that like class like most people don't use a lot of classes, or it's just generally not used, or it just depends on the situation?
Yeah, so it depends on the situation. If basically classes create an object structure, and some programmers don't create as many objects as others. I've seen whole projects that are, it's like two text files is their whole project, right? And they write it out in what's called a procedural format, which is kind of like what we were doing on day one. And the disadvantage is then you can't do that event driven programming, and you tend to get a larger number of errors. Having a prescribed format um, reduces errors. You don't have to, and you can definitely build a program without errors in a procedural format. But especially as things grow, having an organizing structure helps keep it manageable. Does that make sense?
Yeah. Well, no, I mean it makes sense to me. I was just wondering, I've heard you say this several times, like like classes. I like to use classes.
Yeah.
That just led me to believe like maybe there's quite a few people, or there's a very good reason not to, and I just don't. I agree with you.
Yeah.
Does that make sense?
It's Yeah, if I would say if you're doing something small, that it's fine to just use procedural code. But as you grow, an organizing structure is going to help reduce errors.
Well, an organized structure is just going to be better in general. I mean, I don't.
Yeah, it could be a little overhead, you know. Um I'll show you some examples. I'll try and find some examples later on. Let's keep going through the
Yeah, yeah.
lecture. Okay.
Sorry.
No, that's okay. It's a good question. So primary keys, this is what gives it the ID, and it keeps things from getting duplicated. Usually it's an integer or a GUID. And do I have a picture of a GUID handy? No, I'll get one. Oh, we'll see one pretty soon here. Um, Okay, so primary key, every single row has to have a primary key. Um, it cannot be changed, and it must be unique. You know. Uh,
Hmm.
okay, Courtney's out in 45 minutes. So it'll be just in time for homework. She's already knows a bit of SQL, so this is probably helpful, but a little redundant. So generally, the data types are similar but different. What you call a string, they're going to call varchar or text, depending on the database technology. Bool and Boolean, date time, and sometimes they call it timestamp. Some of the names change, but there's usually like a map that says this is equal to this, right? Um, and there's a couple of these kind of discrepancies. So in .NET, it's not a big deal if you're storing 12345 versus 5,768,223, but in databases they block out space to store those values. And so if you're going to have a particular property that only has like the numbers one, two, or three in it, you don't want to block off enough space to store, a billion number value. You just want to store a small integer, right? And so they have these extra data types just to help with size management of the database.
I see. Okay.
Yeah. Null, you saw a little bit of null before. You see a lot more of it in databases. So let's say that you create that record for the first time, right? Think about your constructor in your project and how you had one constructor that didn't have any parameters and another constructor that had name and another one that had several fields, right? So depending on what your first time saving data into a row in a table is, you may make columns nullable or not nullable. And and so you run into this a lot more. And as we start writing some queries, this will make a lot more sense. Uh, and that'll be today. So we'll just get to more a bit. There are four main types of operations called CRUD. You might have remember Eam asking about that a while back. Um, and basically, it's C for create, R for read, U for update, and D for delete. And in SQL, we have commands to match these, except for we call them insert, select, update, and delete.
Mm.
There's also one that kind of combines it, and this gets, uh, sorry, not the slide I thought it was on. Okay. Then, so insert is going to be used to create a new row. Select is to read a row back. And you can do select star, or you can type in the property names that you want. This is really good in the beginning, but once you kind of nail down what it's going to be, just returning the exact ones you need is a lot more efficient. Update, so this modifies an existing row. So you might say, you know, change them from a ninth grader to 10th grader when they uh, finish up ninth grade. Um,
Or for hit points when they get hit. Yeah.
yeah, exactly. Delete removes a row. There's also a concept that we'll get into later called soft delete, where rather than completely removing the row, we will create a little Boolean flag at the end that says if it's active or not. And the nice thing about the soft delete is that it lets you kind of undo that, whereas a delete, it's gone forever. You'll never see it again. You know. Um,
Right.
yeah. So that's soft delete is not a command; it's a way that you build your table and how you handle your updates. Where is setting your criteria? So you could say select all my ninth graders sorry, select all my students where their grade is 9, right? And then update their grade to 10, right? Uh, if you don't have a where clause and you've got a really big database, like hundreds of millions of rows of data and stuff, then you can crash your system trying to pull all that data at once. It's going to try and load it into RAM. And you might run out of RAM and stuff. So where clauses are really important for protecting what you do as well as just keeping the system running quickly. Upsert. So this is a combination of insert and update. I use this all the time. Basically, what it says is if the row exists, then update it. Otherwise, create it. And so that's something we'll get into pretty quickly.
Yeah.
Yeah,
That seems like a useful tool.
very useful. Yeah. Um, so one to many relationships. This is also called a parent-child relationship. And basically, what it is let's say one teacher has bad example. Let's say one student is going to have 6 copies of different textbooks. He's going to have 6 different textbooks. Okay. So if you had
Hmm.
a student table and a textbook table, the student is the parent and the child table is the textbook, right? And and so that kind of sets up a relationship, right? You can say, show me all of Mike's textbooks and show me all of Jonathan's textbooks and use that to um, that relationship to the parent object is part of your where statement.
So
You can
like
also,
a wizard in a spell book.
yeah, 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 or a invoice and then all the items on the invoice, you know?
Yeah,
So
yeah.
this is one of the 2 more common relationships, the other one being many to many, and so I drew this one out. So there we have a list of students, and then we have a list of classes, okay? And John is in math, Yim is in math, John's also in science, Mike's in science, Courtney's in art, Yim is in English. So this student classes table kind of shows the relationship between um, these two. You can do a parent-child relationship with just student and textbook, right? But to get to for something like this, where each student has multiple classes and each class has multiple students, you need a different structure. Okay.
Yeah.
Uh, okay. So this is called. I've seen a lot of different names for this over the years, and it changes, and these symbols mean stuff. Um, but I just kind of want to get you the concept that each each one of these little boxes is a table. Okay, and then these are the things inside of the table. One of the columns is a primary key so that you can kind of separate out one item from another. And these tables have relationships to each other, which are called foreign keys. And and that's how we can kind of structure our data. You know? Yeah. So foreign keys, they enforce data integrity. So basically what that means is that um, if you try and do something that would cause the prescribed data structure to break, it'll throw an error at you. Uh, so if you deleted the parent but didn't say what to do with the kids, as an example, then it won't let you delete the parent. You have to delete the kids first, then delete the parent. Does that make
Mm,
sense? Okay.
yeah.
Or assign those kids to a different parent and then delete the parent. You know, something like that. Um, so that's a safety net, and you'll run into it. Then indexes, these things make things faster. Uh, and I'll give you an example of what an index looks like and how it makes it faster. It does slow down writes. Primary keys are indexed automatically. And you'll want to manually build indexes that match common queries. Okay. Um, it's a little bit advanced for this class, but I want you to understand it as a concept so that if you're out in the real world, you know, writing some code and you say, well, you know, this query is really slow. This is one of the first things to do is see if you have a missing index. Yeah. So this is our student table, right? And it would be really common for me to want to query and say, show me all the ninth grade students or show me all the 10th grade students, right? So the index is sort of like a separate hidden table that takes the number 9 and tags all the students with the number 9 to that record. So if you imagine your loop, I could go through and let's say that this is 30 rows of 30 students here, right? So it's slower for me to go through and search all 30 rows to find the ones that have a grade of 9 than it is for me to look through these 4 rows, right? Find the number 9 and then jump to these 7 records. Does that make sense?
Yeah.
Yeah. So that's why we like indexes, despite their cost for writing, because every time you write a student, you have to then go and update the corresponding index. So it has to write 2 things, you know, which is why we don't index everything. We just index the ones that we use a lot or the ones that are slow. So databases do require maintenance. So your indexes have to get rebuilt from time to time, kind of like reorganizes them and makes them faster. Statistics have to be maintained. You need to make backups of old databases. And then one of the things that makes databases fast is they'll leave empty blocks of space for data. Uh, and then if that all gets filled up, then it writes it to the end. But then when it goes to try and find it, it's no longer in a great spot. And so one of the maintenances is to shift around and add free space. Or if you delete a bunch of stuff, maybe you have too much space and we need to tighten it up. You know, so they're kind of complicated under the hood. There's a lot of things they do to help you out. Um, that are not intuitive and obvious. And the result of all that is they have a little bit of automated maintenance.
Mm,
So SQL tables, they're basically serialized objects. We'll talk more about serialization and what that means later. But for now, just it's your data stored inside this cool structure. Um, primary keys kind of create identity for a record and make it unique, right? So like, for example, you're playing a game and you're Bourguignon, and then somebody else also has a character named Bourguignon. What separates your records in the database and everything that you've done in the game is the primary key, not your name. Yeah. Um, then,
okay.
yep. Uh, Foreign keys create these references so that we can see all the spells that your wizard has, right? Or all the equipment, right? It's these parent-child. It's the way that we join parent and kid instead of like comparing strings like the name Bourguignon to something else like in here. This is this is a really inefficient comparison. If I actually put John and math inside this table, what would actually go in here is John's primary key and math's primary key, and then Yeem's and math, and John's primary key and the science primary key. We would store those, and that's much faster for comparison. Um, okay. All right. So now, uh, that's the slides. Let's take a look at some code. So this is a program called dbeaver, and it's open on your um, virtual machine right now. And in it, you're going to have this engineering bootcamp database. And hold on, let me rename this real quick. I forgot to do that. Okay. All right. And in it, we have a students table, a classes table, and we have student classes, just kind of like in our example, right? These are other databases for some of my other projects. You don't have access to them. You have access to this one, and if you guys mess it up, no worries. We'll fix it. Okay, it's a great one to practice against. So we talked about CRUD operations. So create, read, update, delete, and upsert, right? Combining the two. So
It's not. It's not letting me. When I click on it, nothing pops up.
when you click on what?
The engineering boot camp, and
Let
it
me take a
looks a
look. Hang
little
on a
different.
second.
Yeah.
Oh, yep. No, because you haven't written the queries yet. So
Oh,
what you'll
so
do
what
is
you're
you'll click.
showing me is not supposed to be here. Okay.
Correct. You can see
I
what you're supposed to be able to see so far. So um so one thing to note, if you add a table, which is something we're going to learn to do tomorrow, you do have to right click and do refresh in order to see that table in the list over here. Okay. Uh, so to start writing queries, you're going to hit this SQL button, and now you can start writing them and following along.
okay.
Yeah. Uh, good
Sorry,
question. Now,
I thought I was supposed to see this.
no, no, no. This is what you're going to write. So let's take a look and see which students are in here. So I want to see. I don't. Let's pretend we don't even know what the columns are. Okay. So I want to save that for later. So I'm going to put that up there. So I want to say select star from students. We didn't talk about ordering things yet. We'll save that for later too. Okay. So we used slash slash in C sharp to do comments. In most SQL languages, you're going to do this dash dash. Okay.
Okay.
Um, and this will run everything in the whole screen. I got 5 queries here, and I really just want to do one. So I'm going to highlight the one, and then I'm going to hit this button right here, which is execute. And so on yours, you can do select asterisks from students and then hit execute. Since that's the only thing on your screen, you don't have to worry about highlighting it, but it's good to know that that's an option.
All
Okay.
right. Hold on. Let
Yeah,
me
go
do
ahead.
that. Okay.
You have to delete that and delete the S
Yeah.
for now,
Why
too.
is
I think it was the IntelliSense trying to be helpful, maybe. Something like that. Okay, go ahead and
my
run
bad?
that.
And then it's this
Yep,
one.
that guy right there. Okay, so you can probably make this a little bigger. Yeah.
I need. Yeah. I need
Uh,
to.
yeah, the value window, you don't need this right now. It's handy if you're looking at like a description field or something big, but you can get rid of that right now so that you have some nice real estate, and you can drag this so you can see a little better as well. Um,
Perfect.
yeah. Okay. So now we can see everything, but the thing is, all I really care about is their student ID and their name. So I'm going to take out the asterisks. I'm going to put in student ID, comma, first name, comma, last name. Okay. And then I'm going to highlight that and run it. And now it just shows me those two. And that's a great way to
Three.
make the query faster. Sorry, 3. Yes. That's a great way to make the query faster. Okay. This also has paging. So it's only showing me 200. That's a feature of this dbeaver software. It's not part of the database. Okay. And so that's where um, this where clause comes in. Forget if it's a 1 equal or 2. Okay, yeah, it's mad at me, and it's probably this. Oh, that's right. Okay, so now it's just showing me students who are ninth grade. Maybe I don't trust it, so I want to also see grade right here. Is this making sense? Just like that.
But that cuts down on your elegance, right?
Correct. Yeah, I should trust it. You're right. Yeah. So one of the key things to
Or you
notice
should
is that
just do it. Wait, if you take out the okay, I'm sorry. If you take out the where grade equals 9, is it just going to show you all the grades?
yeah, correct.
Okay. No, so that's not elegance. That's okay. I
This
sorry.
part I need, but if I'm really just trying to see ninth graders, then that's a little bit redundant. You know, because
Yeah.
provided this is correct, then these are all my ninth graders.
But then I could see if you wanted to uh check something, you can make this false, right? You can make the where false, and then
I could do
you
not
get all
equal.
of it, right? Right? Then you can look at all everyone.
No, if I do this, it's gonna show me the ones who are not ninth graders. So the ninth
No, no, no,
graders
no.
are removed. Oh,
How do I make the where line false?
um,
Right? Or how do I turn that line off without deleting the soft delete?
uh, you can comment it out.
And then it'll
There's
show me
not.
all the grades, right?
It'll show me everything. Yeah. So even
Yeah.
though I'm
Okay.
highlighting it to run it because it's commented out, it's not gonna do it.
Okay.
Okay. So now let's enroll a new student. Uh, so first, I want to make sure I'm doing a student ID that's not in there. So I'm going to do 1031. And then we got the student's name, and Sam is a 10th grader. So you'll notice on the insert, it's insert into in this language. Then I specify the table name, students, right? And then I specify the order of these values. So student, first name, last name, gender, grade, but I could also do grade, gender, and then I need to flip these two. So the sequence of the values has to match the sequence specified up here.
Mm.
Okay. All right. So I inserted that. It says so I didn't ask it to, it's not a select, right? So it's just telling me that it updated one row and that it selected it. It says it ran this. If there were issues, it would throw an error like it did when I tried to do double equals, you know. Now if I go look at here though, there's Sam down at the bottom. He's now added into the table. Does that make sense?
Mm.
Okay. Problem is that I put Sam in as a 10th grader and he's actually a ninth grader. And he's ID 1031. So same thing. This is an update, not a select. So it's not showing me the table. I have to come over here and do this. Now, the thing is, this is a lot of scrolling around. And if it's a large table, so really what I should be doing is just saying where student ID equals 1031. And now it'll show me just Sam's record. Does that
Right.
make sense?
Yeah,
Okay.
because you're looking up a single record, his record, his
Yep,
ID.
exactly.
Yeah.
All right. So now uh I want to get rid of Sam. Sam, sorry. Okay. So that's gone. If I run a select, there are no students where student ID is
Yeah.
1031. Make sense?
Yeah.
Okay.
Because you deleted it.
Uh, yeah. Now,
Now, how do you get him to be not at the bottom, but with the rest of the ninth graders? You just look for ninth grade only.
great question. Let's do by this. That's where order by comes in. So let's insert Sam back in. Okay. And then and now, oh, sorry. I made him a 10th grader.
That's okay.
So
But
he's in there with,
he's lumped in with the tenth graders. Yeah.
yeah, and you'll see the IDs aren't there. There, right? If I wanted to do it by um grade, then maybe last name, you can do multiple
Or
and it goes in order from left to right. So first it
yeah,
does it by grade, then it does it alphabetical by last name. If I flip it around, it'll look very different. Okay, so now it's by last name, but then, uh, well, in this particular case, the only time grade would really be doing anything is if I had two reads, for example, right? But it's not going to change the order of the R's. It's alphabetizing the entire last name. Does that make sense?
I see.
So
Yeah.
let's give Nathan a sister. She's older.
Then you insert.
Yeah.
Then you select.
Now Now Natalia appears after Reed
after.
because Reed has a lower one. Yeah.
Okay.
Uh, and then I believe that means descending. So now it's going highest letter to
Oh,
lowest letter.
yeah, it's backwards.
Yep. Yeah. Which also comes in handy sometimes. You know, especially if you're doing like dates and you want to see the most recent ones. That's really
Yeah,
common.
yeah.
Yeah.
I can see
Okay.
where that would be useful, especially for dates.
Yeah. So why don't you go ahead and insert a student into the table? Actually, before you do that, let me run this one more time. We should get an error. Yeah. So it's saying student ID already exists. Remember we talked about those keys, like making sure you don't screw things up? This
Oh,
is an
yeah, it
example.
automatically tells you you already did that.
Yep, and that's why we have this upsert example. But let's work with the four basics before we get into that.
Yeah,
Okay.
thank you.
So go ahead. I'll leave the code up on the screen and go ahead and type some queries, get comfortable with it, do an insert, select, update, and delete, please.
Oh wow. Okay, yeah, this when it's trying to be helpful, it's not being helpful.
Yeah, I'll have to figure out its pattern.
Or I guess just yeah, just get used to it. Mm, no, student ID. So now can I if the list for instance, like if the student ID didn't have the underscore, it just had a space,
You
right?
would have to put it in double quotes, which really sucks. Try not to do that.
So I want to have the underscore.
Yeah. The other thing is, if you expand over here, you can see the columns. So if you want to see how something was spelled, something like that, that's available as well. And it's also showing you the data type.
Well, they're all text files.
Mhm. Exactly.
uh, all right, you have my screen on your screen.
Uh, Sorry. Here you go.
Thank you. So now, why are yours capitalized and mine are not?
Because that's how I typed them. It's just it's
So
a
it doesn't
convention.
matter.
Doesn't matter.
Well, see, look, it's
Oh, it auto change yours down. Yeah. Uh, I don't know. I guess.
no. We'll put him. And then can I just? Yeah. So. Uh,
Oh, did you
oh,
run your insert?
not yet.
Okay.
Huh?
Go
No.
go ahead and
Why?
run it real quick.
Oh. Run it now.
Yeah, go ahead and run your insert. Yeah.
Oh, okay.
Okay, that's a terrible error message. But the problem is you misspelled first.
Oh, I did.
Okay, now run it. Oh no, I see what it is. Actually, it's a relevant error message. It's students plural.
This one.
Yeah,
Oh, students. I was looking at this. Okay.
yeah.
Oh, damn it.
Um.
Oh, order.
Yep. And basically, what it's telling you is that the you're trying to put a string into a number field.
Well, no, wait a minute. So it should still give me the error, right?
No, you should be okay now. Oh, okay. What's that one mean?
Hold on. Hold on. Violates unique students P key. P key.
That's the
Oh,
primary key.
already. Is there already a 1031?
Yes.
Oh, all right. So 10. So could I just say how would I say just
Next available.
yeah,
Yeah. What we
or is
would
that
do
advanced?
in
We're gonna
that
work on that one.
case, yeah, is we would do an identity on that column over here, and then it would auto number it for us. Uh, and then we wouldn't have to input it in at all. We would just say create a new student, and it would assign the ID automatically. I kind of want you to run into these things so you understand how it
Okay.
works. So that's why
Okay.
it's not there. But yeah,
So now it should be fine. Yay! Koa now exists.
yay.
There he is.
Mm-hmm.
All right.
Okay, but the problem is Ko is a seventh grader. So now do your update statement.
So then, oh, I could just do this, but you're talking about an up. You want me to do the update statement?
Yeah. You can't just do insert because that record already exists. You would have to delete it first and then recreate it.
So why do I need that semicolon here? But I haven't seen that anywhere else yet.
SQL is weird about the semicolons. I even I'm not fully under. Technically, at the end of each query, you're supposed to have a semicolon, but there's a lot of times where it's not enforced.
Boy, it likes to give me errors, doesn't it?
Databases are very, very rules driven.
Oh, dude, I am not going to thrive in this. What did I do wrong?
Student ID, then you said a space. You
Oh,
gotta do the
I got to do the Is it equals or
Equal.
okay?
It's equal.
Okay.
Yeah. Uh,
Students grade check.
okay, hang on a second. I don't see what's wrong with your query. Update student, set grade equals a value where student ID. Uh, students violates check constraints. Students grade. Oh, hang on. I didn't know this was in place.
Are we not able to go below 9?
No, yeah, I'm gonna delete that. Okay, go ahead and rerun it.
Yay! There
Okay,
he is. And then I can run
yeah,
this, and then there he is.
yeah. So basically, I had ChatGPT help me make the table because I was trying to do things fast and populate it with all these records and stuff, so you'd have something to play with. And it put a rule in that said only grades 9, 10, 11, and 12 can exist, which is something you can do that, you know.
Yeah, yeah.
Usually I handle that kind of logic up in the application, not in the database. You know? But that's fine. Okay, now go ahead and write a delete statement just so you're comfortable with it.
All right. Let's. I thought we weren't supposed to delete anything.
Well, but you need to know how to do it for when you do need to do it.
I just remember you. Don't delete. Don't ever delete.
Yeah, yeah. It's definitely a good practice to not delete things, generally speaking.
We're gonna act. Who we axing?
You go ahead and delete Koa because
Sam.
then you can reinsert him.
No. Oh, I see what you're saying.
You're gonna get rid of Sam. Yeah.
I was gonna ask Sam.
That's a colon, not a semicolon.
Oh, yeah. I like my shift button. Okay. Okay. So then I'll run this. It's gonna give me an error. Oh my god. Now this.
Okay.
Koa should be gone. Koa is gone. But then I run this. And if I run this, it will bring him back as 9
Correct.
until I run the update, which I will do now. Okay. Then run this. And he's there. Okay. And then how did you do it? I think you said uh
Order by.
order by, yeah, that's it. Order by grade. And then I'll run it and it should all be in order by grade. Perfect. There he is.
Mm-hmm.
Perfect. Okay.
Feeling good?
Uh yeah, I want
All right.
I want more to do. Uh I'll
Well,
probably put
what I would do is, yeah, go ahead and practice adding students or, um, okay, why don't you see if you can figure out, don't worry about upsert for right now, okay? Just focus on these four operations, and why don't you see if you can enroll a student in a class, okay? And what I want you to do is hit this because that will create a second tab for you. So you can come over here and look at what you have here, but you can work on enrolling a student into a class, which, oh, sorry, you have to refresh that. So student classes. So if you go, the slides are now in Discord. Let me pull them up and I'll show you. So it should be, is it primary key, nulls, CRUD? This guy right here. So putting a student into a class, if you're looking at my screen, means you have to look at the class and look at the student and put both their IDs into student classes. See, the IDs, not the names.
Okay, so okay, I have to put. Oh, okay, I see. I see what. So I have to put all the 1001s. Or no, this is the parent.
Here, I'm going to write you a query real quick to help you with your insert. Um, Hold on one second, I'm going to make that disappear. So these are all the students and what class they're in. So to make this just a little cleaner, I'm going to go
Okay.
student ID, first name, last name, gender, grade, class ID, name, teacher. Okay. So you can run this and it'll give you a pretty good idea of what I miss. Line one. Oh, okay. It's going to be 2 days before you can write this kind of query. So that's why I'm writing it for you. Um, so this is your way to kind of test your work and see if your
Oh, I
enrollment.
see. Yeah. And
Yeah,
put them in. These are the
yeah.
classes
So
this ID is in.
correct. Yeah. So try and enroll Koa into English 9, as an example, by using your inserts and stuff like that. Okay? Does that make sense?
Yeah, I think I can muster that out watching everything.
Okay, cool.
So
And
Koa has
then
to be in
English 9.
English 9. All right, let me write that down. Or
And
Discord.
so for like Courtney and Yeem, same thing. Yeem, maybe you want to enroll Sebastian in school and have him take computer science basics or something like that. Whatever you want is fine there. And Courtney, feel same exercise. Create a student and enroll them in a particular course. Okay. Uh,
Okay.
yeah. Yep. There you go. Yeah. If you get stuck, just give me a call. Okay.
Yeah, yeah.
Awesome.
Let me see what I can do. I
Oh,
I feel
I'm gonna put this into the class content as well. Oh, that didn't do it. Okay, hang on a second. Hold, don't move it. The copy's not working. So let me copy it real quick.
yeah.
Okay. So now everybody in engineering boot camp under lesson 5 content, you've got all the sample queries as well as the select one to check your understanding of enrolling and give you something to practice on your own. Awesome. Okay, I'm going to end the recording. And tomorrow we will be doing create tables. But if you get stuck, just message me, everyone.
All right.
All
I speak for everyone.
right. See ya.
Later.